One approach to clustering is called hierarchical clustering, and specifically we'll focus on a type known as agglomerative clustering. To understand how agglomerative hierarchical clustering works, let's go through an example. Imagine we have 5 different objects, each described by 2 variables, an x variable and a y variable. Since we're dealing with only 2 variables, we can plot these objects on a graph for visualization. The process begins by placing each object into its own cluster. Initially, this gives us 5 separate clusters, with each containing just one object. Next, we look for the 2 clusters that are closest to each other, as the assumption is that the closer 2 clusters are, the more similar they must be. In this case, the clusters containing object 1 and object 2 are the closest. We merge them, forming a new cluster. Now we have a 4-cluster solution. We repeat this process by examining the 4 remaining clusters and identifying the 2 closest. Here, the clusters containing object 4 and object 5 are the nearest. We merge them into a single cluster, resulting in a 3-cluster solution. Continuing, we again search for the 2 clusters that are closest to each other. This time it's the cluster containing object 3 and the newly formed cluster of objects 4 and 5. After merging, we're left with a 2-cluster solution. Finally, we merge the remaining 2 clusters into one, arriving at a single cluster solution. This approach, hierarchical agglomerative clustering, doesn't provide just a single clustering solution. Instead, for our 5 objects, it produces 5 different solutions: a 5-cluster solution, a 4-cluster solution, a 3-cluster solution, a 2-cluster solution, and finally, a single-cluster solution. The next logical question is, out of all these solutions, which one should you choose? How many clusters do you actually need? That's a topic for another video. Thanks for watching.